Hello everyone, welcome to YBTC Tutorials Part 1. And today we're going to be talking about the structure of the atom. So here I drew a generic atom right here. This is actually a certain isotope of hydrogen. We'll get to isotopes a bit later. So you can see I put 3 parts of the atom here. They're called the subatomic particles and they make up what the atom is. So the first part here is this positively charged particle. That's called a proton. So it's spelled like this. And the symbol for it is P with a plus as the superscript. A proton is positively charged, as you can tell from here, and protons line the nucleus. Protons also have this thing where they determine which element it is. So, for example, if you look at the periodic table, you can see that carbon has an atomic number of 6. That means that 6 is the number of protons that carbon has, and only carbon has 6 protons. If you add or remove a proton, you get a different element. That's because the number of charges here actually influences the way that these electrons are going to behave. The second part in the nucleus is called the neutron. So neutrons are spelled like this, and they have N as the symbol, lowercase n, so that they don't get confused with nitrogen, and 0 as a superscript. Now, if you couldn't tell already, neutrons have no charge. So even if you have more or less neutrons, they're not going to affect their chemical properties that much. But what it does affect is the mass, because both of these have a mass of 1 AMU. So having more neutrons will make your atom heavier. The neutron also has this role where they try to keep all the protons together. If I add another proton to this atom here, the protons would definitely want to separate from each other. And the neutron's job is partially to hold those guys together. Now, you may have also noticed that neutrons don't actually affect the identity of the atom, nor do they affect the chemical properties, but they affect some of the nuclear properties of the atom, including the weight of the atom itself. In fact, if I change the number of neutrons in the atom, so let's add a second neutron here, now we have helium, which has 2 protons, but helium can have 1, 2, or any other number of neutrons and still be called helium. Those are called isotopes. They have different number of neutrons, i.e. a different mass, but they are the same element. Another example would be with hydrogen. So you can have just 1 proton for hydrogen. You can have a proton and a neutron, or you can have a proton and 2 neutrons. Those are the 3 most common isotopes of hydrogen. You can see they all have 1 proton, so they are hydrogen. You can see hydrogen as 1 proton thanks to its atomic mass or atomic number, but these guys have different numbers of neutrons. We'll get more into this when we get to the nuclear chemistry section. And last but definitely not least, these guys on the outer side are called the electrons. They're called lowercase e with the minus as the symbol, or superscript. The minus indicates that the electrons have a minus charge. And as you may know, opposite charges attract. This electron is attracted to the proton, so it orbits around the nucleus. The reason it orbits the nucleus instead of staying with it is because electrons are 1,800 times lighter than protons or neutrons. So first, they don't actually contribute to the mass. And secondly, that means that they're able to move around. And the moving around of electrons actually determines a lot about an element's chemistry. In fact, if you gain or lose electrons so that you have an overall charge, normally in an atom, the number of protons and electrons are the same and the charge is neutral. But here you can see we have more protons than we have electrons. When it's off balance like that, we call these ions. And when there's more protons than electrons, or in other words, if you lose an electron, you're called a cation. So cations are positive ions. A common one would be sodium ions. And anions would be the opposite. When you have extra electrons, and that causes a net negative charge. An example would be chloride ions. Now the question is, what decides if you become a cation or an anion? And to do that, we have to look at the periodic table again. The goal of any element is to fill up its outer electrons. Generally, that number would be 8 electrons. So these guys all have 8 electrons. So this column 18 right here doesn't want to give up or gain any more electrons. They're happy as is. But you can see group number 17, they have one less electron than the full outer shell. So they will want to gain an electron to become like the noble gases. They want to fill up their outer shell. On the flip side, all the way out here, you can see that these elements are one above the last noble gas. So for example, sodium is number 11, but neon only has 10 electrons. So sodium has the extra electron. So what sodium will want to do is it wants to throw out those electrons. Now you might notice something. We have people who want to throw out the electrons and guys who want to gain the electrons. That's the basis for something called ionic bonding, which we'll talk about later. And that's how something like sodium chloride or table salt can form. Thanks for watching. See you next episode.